Spring Framework is an application framework for Java and JVM languages. Spring was originally built around dependency injection, but it grew to be an entire ecosystem of tools and plugins for Java developers. Spring was originally released 15 years ago, and since then a lot has changed around application development. For example, many engineers today deploy their applications to the cloud in microservices architectures. The expectation around frameworks has also changed, with the rise of Django, Ruby on Rails, and NodeJS since Spring's rise. Spring Boot takes an opinionated view of building production-ready Spring applications. By taking this opinionated view, Spring Boot gets engineers up and running faster than the traditional Spring framework. Josh Long is a Spring developer advocate at Pivotal, and he joins the show to discuss Spring Boot and the history of the Spring framework. Software Engineering Daily is having our third meetup, Wednesday, May 3rd at Galvanize in San Francisco. The theme of this meetup is going to be fraud and risk in software, and we're going to have some great food, some engaging speakers, and a friendly intellectual atmosphere. To find out more, you can go to softwareengineeringdaily.com/meetup. We would love to see you there. We'd also love to get your feedback on Software Engineering Daily. You can fill out the listener survey available on softwareengineeringdaily.com/survey. It would be really helpful to us, and let's get on with this episode. Spring is a season of growth and change. Have you been thinking you'd be happier at a new job? If you're dreaming about a new job and have been waiting for the right time to make a move, go to hired.com/sedaily today. Hired makes finding work enjoyable. Hired uses an algorithmic job matching tool in combination with a talent advocate who will walk you through the process of finding a better job. Maybe you want more flexible hours, or more money, or remote work. Maybe you want to work at Zillow, or Squarespace, or Postmates, or some of the other top technology companies that are desperately looking for engineers on Hired. You and your skills are in high demand. You listen to a software engineering podcast in your spare time, so you're clearly passionate about technology. Check out hired.com/sedaily to get a special offer for Software Engineering Daily listeners. A $600 signing bonus from Hired when you find that great job that gives you the respect and the salary that you deserve as a talented engineer. I love Hired because it puts you in charge. Go to hired.com/sedaily, and thanks to Hired for being a continued long-running sponsor of Software Engineering Daily. Long is a Spring developer advocate at Pivotal. Josh, welcome to Software Engineering Daily.
Thank you. Thank you so much for having me.
Let's start off by talking about the Spring framework. For people who have no idea what Spring is, what is the Spring framework?
So the Spring framework originated in 2002, I guess, is kind of one of the earliest incarnations people might know about it. And it serves the goal of helping people write code without worrying too much about the middleware with which that code is interacting, right? And it did that by letting people use dependency injection, which is it's a fancy way of saying that you write code to interfaces as opposed to and then because you have interfaces, you can plug in implementations. You can swap out implementations, right? So you write code against a data source as opposed to writing code that looks up a data source inside of JNDI, that kind of thing. That indirection makes it possible for Spring to do all sorts of cool stuff for you, because now that you've got this data source or any other sort of collaborating object, you can dynamically subclass the type that you've provided or that you're collaborating with, and you can do aspect-oriented programming. You can provide references to transaction management. You can interpose transaction management, that kind of stuff, all sort of transparent to the component that's relying upon this dependency. So we call that dependency injection. Now that's what Spring started off as, right? But it turns out when you encourage people to write code that's real clean and sort of object-oriented and doesn't have all these tight couplings to dependencies, then you promote unit testing, you promote ease of evolution, you make it easy to move your code from one environment to another, so you get portability, right? That's sort of the original, I think, the motivations for people moving to Spring more than 15 years ago. Since then, it's become a whole ecosystem, and we can talk about that if you want, but I'm not sure if that's your question.
No, we'll get there.
Okay.
So this notion of dependency injection, where you can specify a data source and you have a looser coupling to what the actual end data source is, whether it's MySQL or Postgres or Cassandra, you have some intermediate middleware that is taking care of translating the format of the database to the format of the framework, the in-memory framework, the Java program that's running. Is that
so
accurate? Or not
No,
so much?
I'm sorry. That's more like that's what you're talking about is more of a framework, I guess. No, I suppose you're talking about an adapter. What we are talking about when I'm talking about a data source, I mean, suppose you have specifically a pointer to a javax.sql.data source, right? And what Spring makes it easy to do is to work with a, let's say, in your prototype case, you want to work with something like a H2, right? An in-memory embedded, but still SQL database that complies with javax.sql.data source, the contract. Tomorrow, you may, and again, when I say tomorrow, let's imagine we're in the hypothetical situation 15 years ago. Tomorrow, I may decide I want to move that application that is using my little in-memory database, and I want to point it to Oracle, which is bound into a JNDI context. They're both a javax.sql.data source. This is not about abstracting away unnecessarily the fact that you're using a SQL database versus a Cassandra versus a MongoDB. This is about locational decoupling, right? The reference to the thing I'm using is still a SQL data source. It's just that I, in my code, don't have an explicit requirement that data source be the production instance that we've got in production. I can actually swap out a mock in my test. I can use a in-memory one in my local development environment, et cetera, et cetera, et cetera. At a higher level, there's other things that allow you to talk to other data sources like Mongo and Cassandra, but again, that's an ecosystem discussion.
So back when I was a programmer, all of the jobs that I had were Java programs that involved Spring, and I never understood Spring. I could never understand it, and literally all of my software engineering work was in this environment. What are some of the aspects of Spring that people have historically disliked or not understood?
Well, so, good question. The first thing is to understand that what I just described, this idea of dependency injection, is the least, significant or least relevant part of it. So if you're using Spring just for dependency injection, you're missing out, right? What has happened is people have built frameworks on top of Spring, on top of that basic component model, this idea that you've got a single place where your objects get wired together and they're free to work and to function without any coupling to the other components, these collaborating objects. So we have technology that serve all sorts of use cases, verticals, if you will. Like if you want to build a web app, there's MVC, there's Spring MVC. If you want to do batch processing, there's Spring Batch or integration. If you want to do microservices, there's Spring Cloud, et cetera, et cetera, et cetera. So that's the thing, is that there's this whole ecosystem of technologies. The dependency injection is just sort of how you get there. And I think today, in 2017, we just take for granted that, of course, that code is going to be written in such a way as to not be coupled to the sort of specific reference. Like I'm not going to write code that is today coupled to the IP address for my production database, right? That makes no sense. I would externalize that configuration. I'd have a little bit of indirection there. So as to things that people don't like, I think perhaps one thing that a lot of people soured on eventually was XML, right? So XML was the way that we helped you wire up the objects in your application. So remember, Spring originated. It came from many years before Java 5, and so what we needed was some way to tell Spring, here are the objects in my application. Here's how they're wired together, right? Here are their relationships. If Spring knows about that wiring, then it can do things, as I say. It can interpose itself in between you and your collaborator and provide services for those collaborating objects, right? So the only way we could sort of describe that relationship in the beginning was to use XML. We didn't have the ability to annotate your code with Java annotations in Java 5. So a lot of people, when they think of Spring circa 2005, or circa 2004, they imagine that it's only XML, it hasn't been true since 2006, but nonetheless, there are still some people who are, I think, suffering from that idea. The other thing that I think a lot of people struggle with, not a lot, but certainly enough that I'm going to mention it here, is that there is, as I say, a large ecosystem. So there's a lot of different things you could choose to use in the Spring ecosystem. Maybe you've got a specific use case. You want to build a web application. Well, then, by golly, have at it, use Spring MVC. If you're trying to do security, well, you can use Spring Security and you can layer that into other applications. If you want to do batch processing or integration or that kind of stuff, there's Spring Batch and Spring Integration, respectively. If you want to do data access with all these different sort of specialized data stores, NoSQL data stores, there's Spring Data, right? There's just a lot of different options. And if you're a newcomer coming into the world of programming from university, for example, and you start to look at all these verticals and you think, okay, I've got to learn Spring and they all start with Spring. Where do I even begin? That can be, I have no doubt, a bit daunting. So the main complaint that we used to get is, how do I get started? And for that we have Spring Boot, right? Spring Boot hopes to at least alleviate any kind of friction associated with the actual getting an application to the point where you can write code that is business differentiating. But that still doesn't alleviate the requirement that you understand what you're trying to do, right? You're trying to do batch processing, you're trying to do integration, etc. What it does do is it gets rid of all the configuration, all the sort of boilerplate. So I think those are the two big things that people have historically had trouble with.
Right. Now, there have been a lot of changes to application development since Spring was the framework to rule them all. There have been new frameworks that have come up. There have been obviously the move to the cloud has occurred while Spring has been the predominant framework. And as those things have changed, Spring has made changes as well. And those changes are probably best epitomized by Spring Boot, which is the project that you mentioned. What is Spring Boot?
So Spring Boot, at the simplest level, it is still Spring. It's just an opinionated approach, an opinionated start on top of the Spring ecosystem and then by Spring ecosystem, I really do mean all the things that people use with Spring, not just Spring proper, not just the Spring projects, right? So, and the way we provide that opinion is by providing something called auto configuration, which is this component model that works very much like what you would have done before. Remember, 15 years ago, you would have told Spring about your objects, and they would have all come together at runtime, and they formed some sort of useful thing, right? That would have been a web framework or whatever, right? So they're still there. There's still that. There's still this idea of the objects being contributed to the runtime sort of final state of the application. But what's slightly different is that now we can make it so that those objects are dynamic. They get contributed based on conditions that can be evaluated. So you can say, okay, well, if this class is on the class path, then activate this component. Create this object and contribute it to the object graph, wire it into the collective thing. We can say if this library is here, or if an object of this type already exists, then don't bother, right? But otherwise, do bother. So, for example, if there's a library on the class path, but nobody's already explicitly defined a bean, then Spring Boot will create something for you. That dynamic programming model means that we can provide what we call starters, and these starters are just integrations with all these different ecosystem projects. I mean, if you want to do metrics, or if you want to do security or integration or batch or NoSQL, if you want to do messaging, if you want to do SendGrid, if you want to use Facebook or Twitter or LinkedIn, or do sign in with, or just act as a client to some sort of arbitrary OAuth endpoint, or if you want to talk to a StatsD sort of a time series database, right? I mean, whatever your use case, it's as simple as adding a what we call a starter, which in turn just brings in libraries, which in turn light up or activate these tests that I was telling you about, these aforementioned tests that say, okay, this library is here. If it's there, then go ahead and wire up the default useful sort of set of objects that we need to be able to talk to this thing. So if you have Spring Boot starter RabbitMQ on the class path, that's a dependency, it's a Maven dependency, or you can use Gradle, right? It doesn't have to be Maven, but it's a dependency. If you add that onto the class path, that activates it contributes the auto configuration, the default configuration for RabbitMQ, which in turn points to the local RabbitMQ instance, so on. So it gives you a transaction, it gives you a RabbitMQ template that you can use to talk to it. It gives you a default connection factory pointing to RabbitMQ. So all that work that you would have done to use RabbitMQ is just done for you. But if you at any point want to override the defaults, it's as simple as defining your own bean of the right type, and that'll be preferred, right?
For more than 30 years, DNS has been one of the fundamental protocols of the internet. Yet, despite its accepted importance, it has never quite gotten the due that it deserves. But today's dynamic applications, hybrid clouds, and volatile internet demand that you rethink the strategic value and importance of your DNS choices. Oracle Dyn provides DNS that is as dynamic and intelligent as your applications. Dyn DNS gets your users to the right cloud service, the right CDN, or the right data center, using intelligent response to steer traffic based on business policies, as well as real-time internet conditions, like the security and the performance of the network path. Dyn maps all internet pathways every 24 seconds via more than 500 million trace routes. This is the equivalent of 7 light years of distance, or 1.7 billion times around the circumference of the Earth. With over 10 years of experience supporting the likes of Netflix, Twitter, Zappos, Etsy, and Salesforce, Dyn can scale to meet the demand of the largest web applications. Get started with a free 30-day trial for your application by going to dyn.com/sedaily. That's dyn.com/sedaily. After the free trial, Dyn's developer plans start at just $7 a month for world-class DNS. Rethink DNS. Go to dyn.com/sedaily to learn more and get your free trial of Dyn DNS. So it makes sense to have an opinionated framework in a world where Spring has become a sprawling landscape and marketplace of different options you can choose from, and you covered some of those opinionated views. I think this is similar to, it's almost like a Ruby on Rails on top of the Spring ecosystem. Like Ruby on Rails is opinionated, and they don't apologize for the opinionated position.
Well, if I may, there's a yes,
Please.
Absolutely. We absolutely, the Java ecosystem and Spring especially, we all owe a great debt to technologies like Ruby on Rails, which contributes to this convention over configuration idea. We actually had a previous convention over configuration technology called Spring Roo, which is I think more closely related to Ruby on Rails. It was code generation, right? So the result was that you had code that was generated for you, and the result, I think, for the use cases that we had when Ruby on Rails came out, I think that approach was certainly valid. But so you mentioned that it's appropriate to have an opinionated approach on top of Spring. It's not just Spring, it's just the number of things that a developer in Java is supposed to do these days has just grown just so much more dramatically. So it is asking a lot to have a Java developer be good at all these different things, to remember all the nuances of all these different things. Whereas before, there's only a few things you're likely going to do. You're going to build a web app, maybe babysit it, talk to a database or whatever. What kind of database? Oh, some sort of SQL database. That set of things that your average developer had to deal with has just grown. And I don't know that there is any kind of like common case application today. The way we do this is at runtime. So the object graph is not code generated. And unlike Ruby on Rails, where people have historically sort of struggled to undo the assumptions in the opinionated framework, you can override or undo the assumptions with Spring Boot. As I said before, it's as easy as providing configuring your own object of a certain type. We call that a bean in Spring. It's just an object that you tell Spring about of a certain type, and if that type matches one of the default objects that Spring Boot tries to provide for you, then yours gets preferred, and the other one that Spring Boot would have provided for you gets dropped. Its creation is short-circuited. So the result is that you can now undo. You can because it's a framework. It implements the open-close principle, right? It's open for extension, but closed for modification. Now, obviously, it's not closed for modification. It's open source, so you can do whatever you want to it. But the idea is that you don't have to fork or recompile Spring itself to change its behavior. You just plug in objects of a certain type, and they get plugged into the machine. Cogs in the machine.
Let's imagine I am working in it. Let's take a giant enterprise. Typical giant enterprise that has a big, some just Spring applications internally. I think of
like Netflix or Alibaba.
Sure, Netflix, Alibaba, eBay, Amazon, all the companies I've worked at, and many of the companies that I've interviewed on this show.
Yeah.
So, let's say there's somebody at this organization that wants to stand up a new service, or they just want to do some sort of experiment, and they use Spring Boot, and they stand up their brand new service, their brand new app, and it gets to a scale where they want to integrate it with the pre-existing Spring monolith. what's the pattern for integrating a Spring Boot app with a pre-existing Spring Enterprise monolith?
Well, so that depends. Do you mean it in the same running process, or do you mean as sort of a satellite service to which they communicate over a network process?
Look, whatever is the typical, what is the typical integration pattern you see?
It's really, what we see is that we have a lot of people, we know a lot of organizations are coming at this from the world of the monolith. They have an existing application. And for them, if they're happy in that world, that's fine. They should absolutely, there's no reason to, like for example, if you have a small team and you're 4 people and you've just got this application that's served you well for 10 years, whatever, and it's sort of chugging along. It's not going to ever need more than a few developers, and maybe it's even on maintenance mode or whatever. Then maybe it's simple enough to just move your existing application and move it to the world of Spring Boot and keep it a monolith, right? What we care about at Pivotal is agility, and I don't mean sort of. I'm not trying to speak specifically to
little a agile.
Yeah, a little a agile. Thank you. Right. Yeah, exactly. What we care about is that we care about getting results to production. So if you've got an application and you're able to update it as fast as the business needs, then maybe this newfangled microservices architecture isn't for you, and maybe it's simple enough to move your old application to just move it to Spring Boot. And in that case, it's simple enough because your old application is a Spring application and your Spring Boot application is a Spring application. So what I like to do, and this is what I tell all the people I talk to, add the @Spring Boot application annotation to your code base. Bring in the right libraries, set up your Maven build accordingly. Or if you want to shortcut that step, you can go to start.spring.io and code generate just the preliminary Maven build and the directory structure, and then you can use that as a queue. But anyway, however you get that build set up, add Spring Boot application, the annotation to your existing Spring application somewhere, and then start it up and start, once it's working, start removing code. Find out the components that Spring Boot provides defaults for, and then remove the code that you've already written. And as often as not, it gets to the point where you have just your business logic, your particular components, your servlets and your servlet components, maybe your MVC application controllers or your services or your repositories or whatever, and nothing else, right? Spring Boot should, hopefully, if we've done our job right, provide default auto configurations for the very large majority of the infrastructure code that you may have had to configure before. I like to do this when I have some music, maybe get some alcohol, take the night off. It's a good night, And the next thing you know, you've got a Spring Boot application and like half the code, which is, I don't know how small your application would have to be to remove half the code, but you're going to have very little sort of cognitive overhead. What is left should be just your business logic, the things that you care about.
Well, what's appealing about Spring Boot, or one of the things that's appealing, is it has these developer ergonomics built into it that you don't have with the core Spring or the old world Spring. The things that send shudders down my spine, like the XML configuration, and it looks at Groovy as the desirable language that we should be building our apps around. Can you talk about some of the developer ergonomics that are built into Spring Boot and why you've made those decisions around them?
Sure. So, and by the way, when you say you, I expect you mean the Spring team, of which I'm just one tiny, almost insignificant member. That's right. Yeah. And that team, by the way, is just, they're at spring.io/team. They're innumerable and they're awesome. So I am just the loudest clown on the team. So yeah, some of the things that motivated us in building Spring Boot, developer ergonomics. I like that. Do you mind if I borrow that?
Please do.
The developer ergonomics were motivated by, as you know, this sort of paradigm shift, this move to the cloud, right? And this need to maximize productivity and to reduce the cognitive load. So there's a lot of things that we support in the framework itself, right? We've seen, and by the way, we're not the first. Let's be very clear. We're not the first in a lot of cases to support these things. It's just that we integrated them because they're good ideas, and we try to come by it very honestly. So, for example, one use case that seemed sort of prolific was that people wanted to remove the possibility of drift, right? They wanted to certify that their code that worked on their machine is going to be the same thing that works in production. And so they wanted to remove the drift, and a lot of organizations, especially the high-performing organizations, would take their applications and they'd deploy it to something like a Tomcat or Apache Tomcat or a Jetty or whatever, and they keep that application server binary, the distribution itself, in the code base, right? So the application server configuration lives with the code. It evolved with the code. It moved through development, Q&A, staging, and it went through the continuous integration environment, etc., all in one sort of part and parcel thing. And that tells us that a lot of developers want to guarantee that if it works in CI, then it will work in production, right? They don't want drift. They don't want to have to take their binary and to deploy it to some other thing that is potentially running other things on it that hasn't been updated to the same releases and patches and so on. So they've removed that, and that tells us that a lot of people treat these things as the same thing, even though the traditional deployment models would have you keep them as two separate things, one developed by developers and one managed by operations, right? Now, of course, we've got DevOps, so there's that unification, this idea that both sides of the team are working on the same thing. So we see that manifest in terms of embedded application servers, right? Embedded containers. So embedded Apache Tomcat, embedded Jetty, embedded Undertow, which is, for those of you who haven't heard about it, it's this amazing embedded servlet container from the folks at Red Hat working on the JBoss application server, or Wildfly, right? Now it is. And so you can support those are all supported by default out of the box. Of course, you can still deploy it to a traditional servlet container environment if you like, but by default you get a public static void main application. We also sought to really bake in sort of the best of breed patterns, right? Patterns around building applications that are destined for the cloud. And I think the folks at Heroku did an amazing job with the 12-factor manifesto from 2008, 2009, right? A lot of great ideas in there. One that features prominently is this idea that configuration that changes from one environment to another, things that should be different in each environment, like passwords and locators and that kind of stuff. This configuration should live external to the application itself, outside of the binary, so you don't have to recompile. So Spring Boot supports that kind of externalized configuration. It's a first-class thing, right? What else? We've seen that a lot of people are doing, this idea of having an application with a server-side generated web application, all in the same binary as the business logic itself. That isn't really as common today, right? I think you'll agree it's far more likely you're going to be talking to a REST service, So we've prioritized making REST and building services as opposed to building, let's say, JSP or JSF applications, a first-class citizen, right? You can do those things still, but it's not what we see a lot of developers doing. They're building client-side JavaScript, they're building Android or iPhone devices, clients and so on, talking to services in the back end. And I think that underpins a lot of what we're doing in the ecosystem at large, and that's just sort of come together in Spring Boot.
Can you talk more about how Spring Boot interacts with Pivotal? So you work at Pivotal. Well, Pivotal owns Spring, or they are responsible for Spring. Or maybe just talk about the relationship between Pivotal and Spring.
Let's see. Spring, it was a open sourced, I suppose you'd say. Rod Johnson released his first book, and that source code became pretty popular, and so it took on a life of its own as a repository in SourceForge, and that code then became very ubiquitous, and they formed a company around it that was called Spring Source. That technology, that company grew to the point where in a recession economy, even in 2009, they were bought by VMware for $420 million, something like that. And then VMware managed the projects and the teams that work on it. And by the way, during that time, Spring Source had, it became a hub for all sorts of really great technology. So the lead developers that work on a lot of the big Apache projects, not the least of which, of course, is Apache Tomcat, were employed by a company called Covalent, which Spring Source bought, right? So we to this day have done and still do just a large majority of the commits to things like Apache Tomcat. And for a while there, even HTTPD, right? At Apache HTTPD, that was the technology that we worked on. We eventually acquired RabbitMQ. We acquired Gemstone, which is the company that makes the Gemfire data grid, right? Which is now called Apache Geode. So all these sort of great open source bits under one roof. And then in 2013, EMC, which owns VMware, and VMware, which managed the Spring projects, along with VMware, they all sort of saw fit to say, okay, there's this new direction, it's a different direction, it's worth walking that path, and so they created a company called Pivotal. And Pivotal is sort of the integration of, building applications destined for the cloud, and we have a platform called Cloud Foundry, which is also open source, is managed by the Linux Foundation. These technologies are sort of all sort of at the intersection of, building applications destined for this new environment, this new world. And Pivotal sponsors a lot of the developers that work on Spring, but by no means the only developers. It is a vibrant open source project on GitHub, so we have just a crazy amount of activity on the projects. And I think that's about it. I think that's what you're asking, right?
Don't let your database be a black box. Drill down into the metrics of your database with 1 second granularity. Vivid Cortex provides database monitoring for MySQL, Postgres, Redis, MongoDB, and Amazon Aurora. Database uptime, efficiency, and performance can all be measured using Vivid Cortex. Vivid Cortex uses patented algorithms to analyze and surface relevant insights, so users can be proactive and fix performance problems before customers are impacted. If you have a database that you would like to monitor more closely, check out vividcortex.com/sedaily. GitHub, DigitalOcean, and Yelp all use Vivid Cortex to understand database performance. Learn more at vividcortex.com/sedaily and request a demo. Thank you to Vivid Cortex for being a repeat sponsor of Software Engineering Daily. It means so much to us. Yeah. So when you talk about these different open source projects, so for example, the Gemfire database or Gemfire system, I did a show about Geode, Apache Geode, a very interesting in-memory grid system for managing distributed systems or distributed objects. What's the general pattern for what projects Pivotal wants to take on?
Aha. Well, so that's interesting. When you say projects that we want to take on, what do you
projects that Pivotal wants to contribute to or support or build service contractors on top of or consultants, I guess. Like, what are the battles that you pick?
Aha, very good. So again, what underscores what we're doing is this idea of agility, right? Little a agility. And we see that as a continuum. We see that if you're just doing agile software development, but the rest of the organization isn't doing that, you're not going to get anywhere, right? You're going to be bottlenecked downstream at some other point in the workflow. And so you really need to sort of think about the sort of holistic picture. And so we have a consultancy called Pivotal Labs, right? That they were bought by EMC, and that became part of the Pivotal adventure. They are a company that had been around for better part of 2 decades before Pivotal itself, and so they're now part of the family. We have the Spring Source technologies. We have Cloud Foundry, which came from VMware. So we have all these sort of technologies, and the unifying thing that we care about is helping organizations deliver software faster. And if you think about what that implies, it means you've got to be able to think about how to build software efficiently, right? So we help people learn how to build better software. They come into our offices, we do pair programming, we do continuous delivery, we teach them how to do continuous delivery. And we care about all the sort of the knock-on effects of moving to that approach. When you move to continuous delivery, and you have a lot of different teams moving to continuous delivery, what you want to do is make it easy for these teams to deliver software independently of each other, right, at their own cadence. Well, of course, I think, and I think a lot of people would agree, the logical sort of conclusion of that is microservices. You decouple otherwise sort of independent things into separate processes. And of course, when you do that, now you have things that you need to manage and run and scale and operationalize. And if the cost of operationalizing your services is prohibitive, then you won't do it. And so you'll just be stuck in this monolith, which has even more gravity. So we need a platform. You need something to operationalize that and to manage it and so on. That's what Cloud Foundry does. When you move to microservices, suddenly your data workloads become different. Your use cases become different, right? There's communication across processes that has to happen. So you have microservices themselves. These are, they have reliability patterns that they need to care for. So we have Spring Cloud and Spring Boot for that, right? And when you have services that need to talk to each other as well, there's messaging. So that's RabbitMQ. And of course, data. Again, we talked about Gemfire, but which is now Apache Geode. The ability to process large amounts of data, especially the kind of data that's coming off from these different services, and to analyze them in a single place, and then turn that back into insight is important as well. So there's a continuum, and we just see it moving. One of these things they sell themselves once you get to that step in the path. Once you understand that you need microservices, then the next logical thing is you need something to manage the complexity implied by moving to a distributed system, which is where we think Spring and Spring Boot can be very useful. And of course, when you get to lots of different services, you need to operationalize them. You need Cloud Foundry and the communication between these services and the integration of data. That's something you have to care about, perhaps using something like Apache Geode and so on.
Okay, makes sense. Yeah. Okay, so the big picture is coming together. Is there a standard model that you're seeing around how people are building those distributed systems with different Spring microservices? Can you talk more about the general picture for a microservices architecture that uses Spring as the main template for services?
Sure. So this isn't our picture. Well, it's, slowly it's starting to become our picture, but it's certainly, we're not the first to originate these ideas. Let's be very clear. We're very lucky right now in 2017 to be able to look back over the last 10 years, and we can see that countless organizations have attempted this migration, this journey, right? They've attempted this journey, some more successfully than others, to this idea of cloud native. We talk about that all the time, cloud native, and my book is called Cloud Native Java, right? But I think the most famous of these has to be companies like Amazon and Netflix, right? So these patterns, these best practices, these guideposts on the way, they've been out there. A lot of people have seen them, and a lot of the good ideas that people have discovered or sort of realized would help them on the way are already well documented. So we sought to codify a lot of these patterns to integrate best of breed technologies from the ecosystem wherever possible, and to make it easy to build applications that take advantage of all these things. So, for example, a common use case in building microservices is service registration and discovery. So we have Spring Cloud. Spring Cloud has support for service registration and discovery. You can talk to Apache Zookeeper or HashiCorp's console, or you can talk to Netflix Eureka. I mean, there's that, for example. Another pattern that becomes very useful when you move to this architecture is centralized configuration, reloadable, encryptable, secure, centralized configuration, keys and values, things like password locators, that kind of stuff. Auditable, right? So we have a config server, but we also support drawing configuration from things like Zookeeper, right, and console. Another thing that becomes useful is security. How do you secure a bunch of microservices and support things like single sign-on? Well, we have Spring Cloud Security, which brings in support for OAuth and acting as an OAuth client, and we have an OAuth authorization server that you can use as well. All of this is open source, of course. Where there are use cases for which we couldn't find a clear and obvious standout solution from the ecosystem, then and only then have we plugged the gap with our own code. But what we're trying to do is to take these brilliant sort of technologies out there and make them as accessible as possible. And where appropriate, provide an abstraction, right? A common interface. So the service registration and discovery use case is a good one. We have an interface called the discovery client. If you can adapt your service registration and discovery vehicle, your mechanism, into that interface, then you can use it in Spring Cloud consistently, to do client-side load balancing, to do declarative REST clients, to do whatever, just by swapping out the implementation. So there's a lot of these sort of patterns, right? And we bake them into Spring Cloud, and that's all building on top of Spring Boot.
What's being worked on today in the Spring Boot project?
Spring Boot, right now, as we speak, our engineers are hard at work on Spring Boot 2.0. And Spring Boot 2.0 we expect will drop at the end of the year, hopefully in time for our big Spring One platform conference here in San Francisco at Moscone. And what is sort of interesting about that release is that it'll be the first to build upon Spring 5, which in turn features a reactive runtime, right, based on our Reactor project. So the sort of work that a lot of the industry players have been doing around reactive programming in the last 5 years, 6 years, has become it's kind of reached a critical mass, and that work, a lot of the key idea behind that is extracted out into 4 interfaces that are now part of the Reactive Streams initiative, to which Pivotal, Red Hat, Lightbend, Nay, TypeSafe, and what was the other one? Netflix are all party, right? And that Reactive Streams initiative is something that underpins our particular reactive framework called Reactor, and then that in turn is what we're using to build a fully reactive web runtime that isn't necessarily based on the servlet engine, servlet API. So it's built on Netty. It's a reactive runtime end to end. You can build REST services, build web applications, that kind of stuff. But for reactive programming to be useful, it really has to be end to end, right? What good is having a reactive REST API if you're still bottlenecked at some sort of code in Spring Security that's using a thread local, right? You're defeating the gains by moving to that architecture if at some point you're doing blocking data access or doing blocking security and so on. So a lot of what we're doing on the Spring team this year is to make the rest of the Spring projects, including Spring Boot, play well with reactive, this whole reactive initiative, right? And so Spring Boot 2.0 will be the sort of integration of all that, right? You'll have all these things that you're used to, but now there's the option to use the fully reactive sort of experience to build upon that.
Cool. All right, Josh. Well, I want to thank you for coming on Software Engineering Daily. It's been great talking to you about Spring and Spring Boot.
Hey, it was my pleasure. Thanks very much for having me. I appreciate it. If there are people out there who want to get started, start that spring.io. I encourage you to give it a go.
Great. All right. Well, thank you. Deep learning is at the forefront of evolving computing and promises to dramatically improve how our world works. In order to get us to that bright future, we need new kinds of hardware and new interfaces between this AI hardware and the higher level software. That's why Intel acquired Nirvana Systems, a platform for deep learning. Intel Nirvana is hiring engineers to help develop this full stack for AI, from chip design to software frameworks. Go to softwareengineeringdaily.com/Intel to apply for a job at Intel Nirvana. If you don't know much about Intel Nirvana, you can check out the interviews that I've conducted with engineers from Intel Nirvana. And those are available at softwareengineeringdaily.com/Intel as well. Come build the future of AI and deep learning at Intel Nirvana. Go to softwareengineeringdaily.com/Intel and apply to work at Intel Nirvana. Thanks to Intel Nirvana for being a sponsor of Software Engineering Daily, and I've really enjoyed the interviews I have done with the Intel Nirvana staff. I think you'll enjoy them too.